Hi guys, welcome to a Guru channel. So in this video we are going to discuss about battery bank in a power generating station or in an industry. Before going to the video, please watch the content of other videos. If you like the content, do subscribe the channel. So coming to the content, the role of battery bank in a power generating station or in an industry. The role of battery bank in a power generating station is similar to the role of an inverter which we are used in our houses. So an inverter consists of a battery. So whenever there is an AC supply, the battery charges through the inverter. If the AC supply fails, so this battery discharges through the inverter and supplies to the our household loads. Similarly, in a power generating station or in industry, the battery bank is used as a backup emergency supply. So, but the application of these emergency DC supply is different. So here, 220 volts DC system is used in many of the power stations or industries. So these 220 volts DC system supplies an emergency supply for control applications, nothing but for control circuits or for signaling circuits, and for relays. Relays are used for the production and the tripping off and closing of the switch gears, and for emergency motors of your most important auxiliary systems. So here the application of 220 volts DC system had a wide range. So these are the some of the applications, like we can use in a control circuits and signaling circuits, relays, tripping and closing of switch gears, emergency motors of the most important auxiliary systems. So let us see one by one. So first, coming to the control circuits, here I am taking idle generator as an example. In case of idle generation in generators, so these emergency DC supply is used for the backup supply for the governor operation. The governor operates the wicket gates in case of the unit starting and unit stopping, and for a regulation of the load. So here in an emergency condition, we need to close the wicket gates. So whether there is an AC supply available or not, we have to close the wicket gates. That command is given by the governor. So that governor uses the this 220 volts DC supply as a backup supply, and it closes the wicket gates whenever there is an emergency. The second one is the signaling circuits. Signaling means in industries or in power generating stations, the communication lines, nothing but the communication signals are also transmitted through the power lines. So that is called it as the power line carrier communications. So so here the high frequency carrier signals are transmitted through the power transmission lines. That's why it is called as a power line carrier communication. So here at the sending end, we need to modulate the source signal, and at the receiving end we need to demodulate the that high frequency carrier signal. So for modulation and demodulations and other purposes, so these power line carrier communication setup uses the this 220 volts DC supply as a emergency backup supply. And the third application is the most important application of the 220 volts DC supply is that is used for the emergency DC supply for the production of the system. In case of the generator, for generator production, we are using the DC supply as emergency DC supply. So because we cannot rely on AC supply 24/7. If there is any fault at the outside of the power generating station, the interruption of the AC supply is exists. So here some of the generator production relays are stator and rotor at the fault relays, and stator rotor overcurrent production relays, overflux production, low forward power and reverse power production, over voltage production, bus bar production, generator transformer production. So these are the some of the production relays which uses the DC supply for production of the generator and the turbine. and the last one is under and overflux protection. So because this protection has to be there 24 by 7 whether there is an AC supply exist or not. So that's why we are using the 220 volts DC supply as the backup supply for these relays. So next one is the tripping and closing of the switch gears. So here the application of the protection, nothing but if there is a fault, the relay senses that fault, and this will give the command to the switch gears for tripping and closing of the switch gears. So here one of the example is GCB, nothing but generator circuit breaker operation during emergency condition. So one of the criteria is if there is a fault at the generator side. Suppose we are having the rotor at the fault or stator at the fault. So that fault will be detected by the stator at the fault relay, and that will trip the generator, nothing but that will close the wicket gates. So then there will be no water flow. So then there will be no mechanical energy. So if at that instant, if the generator circuit breaker is not tripped, nothing but if it is not opened, whatever the power supply is there, whatever the energy is there at the grid side, so that will flow into the generator. That we will call it as the reverse power flow. So that for that we need to have a reverse power relay. So that reverse power relay will senses if there is any power flow from the grid to the generator. So that reverse power will be sensed by the reverse power relay, and that will trip the generator circuit breaker. So then that will isolate the generator from the grid. So if this reverse power if this reverse power flows through the generator, so then the stator winding may get damaged because of the overcurrent. So that can be avoided by sensing the reverse power by using the relay and then tripping the generator circuit breaker. So in order to trip that generator circuit breaker, the reverse power relay have to act. So that reverse power relay uses the 220 volts DC supply as a backup supply. If there is no AC supply, then that reverse power relay will act by using the 220 volt supply. So likewise, all other relays uses 220 volts DC supply as the emergency backup supply, because we need the protection 24 by 7. And next one is last one, the emergency motors of most important auxiliary systems. Nothing but in case of hydro generator, thrust bearing plays an important role, because all the weight of the generator and turbine will axially put into the thrust bearing. So here we can see the thrust bearing pads. So here we can see the thrust bearing pads. The total weight of the generator lays on the thrust bearing pads axially. So these thrust bearing pads are stationary. So when we are opening the wicket gates, turbine will rotate, generator shaft will rotate, and the upper part of the thrust bearing pad, nothing but the thrust runner disc will rotate. So then the amount of heat is generated at the thrust bearing. We need to provide a cooling system. So for that cooling system, we have to use some motors. So those motors must be DC motors, because so that DC motors have to cool the, nothing but have to circulate the oil into the thrust bearing some whenever the unit is running. So that's why we need a continuous supply for those thrust bearing motors, thrust bearing pumps. So those thrust bearing pumps will get the 220 volt supply as a emergency supply. Then that will continuously cool the whatever the oil present at the thrust bearing pads. Similarly, for a steam turbine is nothing but it is an horizontally mounted shaft. So this horizontally mounted shaft is having thrust bearing like this. So here also the same principle, the lot of amount of heat is generated at the thrust bearing tank, thrust bearing pads. So that heat has to be cooled by using by circulating the oil. So that oil can be circulated by using the DC pumps or DC motors. So that DC motors will get the supply from the 220 volts DC supply. So these are all the some of the applications of the 220 volts DC supply. So mainly 220 volts DC supply is used so when there is a need of an equipment 24 by 7. So those are designed with DC that can be fed with a 220 kV battery bank. If there is a failure of battery bank, we need to stop all the units, because if there is no DC supply, we don't have the backup supply for the production. We can't run the power station or an industry without having the production. So that's why a 220 volts DC supply is must and should for a power generating station or in any industry. So that is mandatory. So thank you guys. Thank you for having your time.